I am part of the Adversarial Networks research. And this fall semester, we are going to make a presentation about adversarial techniques for face recognition models. The team consists of 5 members, starting with Abdiel Cortés, Alanis Caro, Brandon Cobo, Luis Efequiles, and myself, Fremio Totero.
Project description. I'll be introducing some definitions and then I'll go into details with the description and an example. So let's begin. We have a face recognition system, that is a technology capable of recognizing a face and assign an identity. These systems are vital for modern biometric recognition systems. Now we have an adversarial attack. This is the method that generates adversarial examples. And now, an adversarial example is the input to machine learning models that are designed to cause a model to make a mistake in their predictions. Our research focused on developing adversarial techniques to full face recognition models. Here we have an example. We have this legitimate example of a picture that says stop sign and is recognized as a stop sign. Now, once you put the adversarial perturbation, you end up with the same image as a stop sign, but now is recognized as a yield sign.
The mission of our team is to evaluate the performance of the most effective face recognition models, and for this we propose to develop an adversarial learning framework based on 4 attacks, which are deepfakes, colorful, defense scan, and data poisoning.
So the type of adversarial attack that I've been researching this semester is the attacks that are under the deepfakes umbrella. So what a deepfake is any kind of adversarial technique that is based on some deep learning technology with the purpose of synthetically creating or modifying an image of the face of a target person. Now, what we mean by that is where you use deep learning to, in some way or form, take the face of one person and implant it into the body of another person.
Adversarial attack, colorful semantic adversarial. This attack generates a small perturbation to mislead the classifier, have limited success in a black box setting with unseen classifiers. This generates unrestricted perturbations and are more robust to defenses. These are generally more successful in black box settings and are more transferable to unseen classifiers.
DefenseScan is a framework that uses generative adversarial networks to train classifier models and defend network systems. It does this by, when detecting a potentially adversarially modified image, it uses a generative model to generate a similar image that is not modified. The generated image is then used to retrain the classifier model.
Data poisoning is an adversarial technique based on the injection of corrupted data with the goal of affecting the resulting model after the training. There are different types of attacks such as white box, gray box, and black box. The focus of our work will be on white box attacks, which basically are attacks where the attacker has a complete knowledge of the internals of the system to be attacked. Here in this figure, we can see an example of data poisoning attack on an autonomous vehicle system, where the model gets affected by affecting the camera and LiDAR sensors. For the accomplishments this semester, we have completed the machine learning course at Coursera and completed the literature review on the adversarial attacks and decided which attacks to implement. Also, we have identified the datasets to be used and evaluated and decided on the platforms to be used next semester.
For the next spring semester, we're going to work on setting up the face recognition model for a system. Also, we're going to fully implement the techniques we just talked about, and once we have all of these attacks implemented, we're going to compare the effectiveness of each one of them related to a different data set. Our final stretch goal for the next semester is going to, based on the information we've collected on this semester, see how we can make these attacks work less efficiently in a face recognition model.